Welcome back, everyone. Or, well, welcome to this explainer. If you're looking to seriously level up your development workflow today, you are absolutely in the right place. We're going to be diving into a masterclass on how to take that sweet, out-of-the-box AI coding agent of yours and transform it into a total, scalable debugging powerhouse. How? By giving it actual eyes into the live browser, using Chrome DevTools for agents. Okay, but before we jump right into the fix, let me ask you something. What exactly happens when your standard AI coding agent hits a weird runtime error? Like, say it hits an undocumented internal authentication error on a sign-up form. I'll tell you what happens. It completely spirals. It just starts desperately searching your static codebase for some cryptic bug code, hits a dead end, and honestly just starts guessing. And why does it do that? Well, because the answer literally isn't in its training data, and it for sure isn't in your source code. And this right here brilliantly illustrates the core difference we're talking about today. Think about a blind agent. It's stuck only seeing your static source files. It's kind of like trying to solve a puzzle in the dark. But an agent equipped with Chrome DevTools, that's a game changer. It can actually see the live document object model, it can inspect failing network requests, and it interacts with the actual runtime data. It does exactly what you and I do when we're hunting down a nasty bug in the wild. So let's dive right into this. Here's our syllabus for today's explainer. First, we'll look at the AI debugging blind spot. Then, connecting agents to DevTools. Third is scaling complex performance testing. After that, live debugging with AutoConnect. And finally, critical browser security risks. Let's get to it.
All right, Chapter 1, the AI debugging blind spot.
So picture this. You're trying to register on a website, and the whole thing just fails with this super cryptic message, right? Something like app_error_3000. Now, as a human developer, what is your immediate reflex? You right-click, you pop open DevTools, you head straight to the network panel, and you inspect the failing API response to see what the server is actually complaining about. The real error lives right there in the dynamic runtime data. But an AI without DevTools totally misses it. It can't open the network panel. So the big takeaway here is absolutely crucial. If we want our AI to fix real-world problems, we literally have to let it see the live runtime data.
Okay, moving right along to Chapter 2, connecting agents to DevTools.
Now, the actual architecture for this is surprisingly elegant, and honestly, it uses tools you're probably already super familiar with. Step 1, you just install a core NPM package. Any machine running a recent version of Node.js will do. Step 2, configure your agent to use it. You can do this either through the Model Context Protocol, the MCP server, or just via command line interface. And then step 3, this is where the magic happens. Behind the scenes, the system connects securely to Chrome using Puppeteer. Yep, Puppeteer, that trusty workhorse library from the Chrome tooling team, is literally doing all the heavy lifting behind the scenes to translate what the AI wants to do into actual browser actions.
To make this connection completely seamless, you just need to make a tiny tweak to a config file, depending on your specific AI tool. So if you're rocking the Gemini CLI, you're usually going to look for a .gemini/settings.json file. Using Cloud Agents, that'll likely be right in your project root at .mcp.json. Just locate that file, drop a new entry into the arguments array, and you are officially off to the races. Simple as that. Let's jump over to our third chapter, scaling complex performance testing. There's this brilliant quote from Matthias Romer over at Google I/O. He said, Chrome DevTools for agents enables you to scale your expertise. And man, that really hits the nail on the head. Just think about it. What if you're looking at a dismal 57-point Lighthouse score, and you literally don't know the first thing about web performance optimization? Well, by giving your AI the right auditing tools, you don't even need to be a performance guru anymore. The AI basically becomes the expert for you.
You know, if you just hand a generic prompt like, hey, improve performance, to a regular out-of-the-box coding agent, it's just going to slowly burn right through your token budget. It'll read all your project files and just start throwing random, unverified code guesses at the wall. But hook it up to DevTools. Now it's running automated AI audits. We're talking real performance traces running actual Lighthouse scores, accessibility checks, and even SEO best practices. It's actually testing for known problems against the real targets rather than just taking shots in the dark from your source code. And if you're wondering how well this actually scales in the real world, just look at this adorable yet wildly powerful case study from a partner named CyberAgent. They set up an agent, gave it DevTools access, and just let it loose on their UI library. It audited over 230 storybook stories across 32 different components in literally 1 single hour of runtime. 1 hour. I mean, just imagine the manual QA hours saved there. It's absolutely staggering when you think about it.
Which brings us to Chapter 4, Live Debugging with AutoConnect. Okay, I'm going to be honest, this is the absolute magic trick of this entire explainer, the AutoConnect superpower. So what is AutoConnect? You can basically think of it as sharing your screen with your coding agent. It allows the agent to latch onto a Chrome instance that is already running. Now, why is this such a big deal? Imagine you're deep into a complex, authenticated user flow. You're fully logged in, you've clicked through like 5 nested menus, and boom, the error is staring right at you. Without AutoConnect, you'd have to write an exhausting, massive prompt just to explain to the AI how to navigate back to that exact state. But with AutoConnect, the AI just picks up exactly where you left off. Zero context lost.
And setting this up is beautifully simple, just 3 steps. Step 1, crack open Chrome Inspect. Step 2, click on Remote Debugging right over in the sidebar. And Step 3, just toggle that little checkbox that says Allow Remote Debugging for this browser instance. Once you do that, and make sure you've got the AutoConnect flag enabled in your config.json, boom, the very next time you prompt your coding agent, it instantly jumps right into the exact browser window you're already staring at. It feels like magic.
All right, last but definitely not least, Chapter 5, Critical Browser Security Risks. Okay, we need to have a quick, serious chat here. By default, when DevTools for Agents spins up a browser using Puppeteer, it runs on an anonymous profile. That's a good thing. It's safe, it's sandboxed, and crucially, it absolutely cannot read any of the passwords you have saved in your Chrome manager. However, and this is a massive however, when you use that amazing AutoConnect feature we just raved about, the agent is connecting to the browser you are currently using. That means it might be using your actual personal profile. It's logged in as you, it has all your cookies, and it can take actions that have very real-world consequences. Which brings us to the terrifying number 999. Why 999? Well, let's say your agent is auto-connected to your logged-in personal profile, right? And you accidentally, maybe jokingly, prompt it with, hey, go to google.com/shopping and order 999 colorful balloons. If you're already authenticated and logged in, the agent has a shockingly high chance of actually pulling that off. Literally, all it has to do is click next and continue at the checkout. Before you know it hit you, your bank account takes a massive hit, and you've got 999 kawaii colorful balloons showing up at your front door. No joke. So please be incredibly careful with what you prompt when your AI has the keys to your personal logged-in profile. And just like that, we've reached the end of our explainer today. We've taken our poor, blind coding agents and given them the ultimate superpower, the ability to see the live web, crunch real performance data, and jump seamlessly into our active debugging sessions. So I want to leave you with this final provocative thought. If your AI agent can now actually see, debug, and test the live web exactly like you do, what impossible project are you going to build next? Thank you so much for joining me today. Stay curious and happy building.